Hi, this short video will show you how assessments can be made using this online tool. So in this decision model, we have three distinctions that need to be assessed. One is success of intervention, the other two are minor injuries given success and minor injuries given failure. So let's focus on this one, success of intervention. This is about the chance of success that the intervention will provide the effect we hope to see. And that's very clearly defined in the model as in a shift in our distribution of minor injuries and major injuries. So to assess this, let's play a little game. You can either choose to bet on the success of the intervention or on the wheel here landing orange. And depending on what you bet on, if you win, you'll get $2 billion. So there's no charge for playing this game, but you can only play once. And because the stakes are really high, we have to think very carefully about this. So if I wanted to play this game and I'm like, okay, the chances of succeeding, let's look at this deal. There's a lot of orange here. Would I rather bet on this or would I bet on the intervention succeeding? I think I would prefer to bet on the wheel. I think I have higher chances of winning. Okay, so I'm going to click on this button which says bet on the wheel landing orange. Oh, now the orange has decreased. What about now? I think I'd still bet on orange. What about now? Um, Now I think I would bet on success of the intervention. Okay, what about now? At this point, I'm not sure. This is great. When I say I'm not sure, that's the point at which I'm indifferent. So I click indifferent and boom. From this process, the chance of success of our intervention is 18.75%. This is what we needed to find. And so when I close this window, you see that when I go to the model, it already reflects this assessment. It's 18.75%. Now let's go into this distinctions that are not binary. So success was about yes, you succeeded or no, you didn't. But minor injuries given success is more about distributions. So here you can see, for instance, we have a high, medium, low of the number of minor injuries in both cases given success and given failure. So going back here, let's do minor injuries given success. So the first thing we are asked to do is to pick a range. What do we think the minor injuries are going to range from? So I'm kind of happy about this range, 0 to 200. Now the important thing about this is to remember that when we declare a range, what we're really saying is we are willing to be shot if the distinction resolves to something that's outside the range. So there were 250 injuries in the future. If that happens, I'm willing to be shot. That's how sure I need to be. So it's very important to have a large enough range. So 0 to 200, for instance, is a good range for minor injuries, let's say, for now. Now I click next. We have a similar game, but it's a little different as well. So the game this time is I can either choose to bet on minor injuries given success being over 180 or on the wheel below landing orange. Now, if the program is successful, what do I think the minor injuries are going to be around? I don't think it's really going to be even close to 180. So I would bet on orange, 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 orange. Okay, something like this. At this point, I'm indifferent. Next question. Minor injuries given success being below 20. Would I rather bet on that or would I bet on the wheel landing orange? I think it's going to be above 20, so I'm going to bet on the wheel. Now, maybe I'll still bet on the wheel. Still bet on the wheel. Maybe around this point, I'd be indifferent. Maybe by some great stroke of luck, it could be below 20. Okay. Third question. You can either choose to bet on minor injuries given success being above 150 or on the wheel below landing orange. I think this is really small. Okay. What about below 50? Below 50. I think it's going to be a little above 50, so I'll bet on the wheel. What about now? Not sure. Maybe at this point I'm indifferent. there could be a chance, some chance that it's below 50. What about above 120? I don't think so. I don't think so. At this point, maybe if the thing was totally unsuccessful and by some crazy stroke of luck, it could be, or misfortune, it could be about 120. Okay, something like this. All right, at this point, I'm indifferent. Below 80, I'm pretty sure it's going to be below 80. So I will not bet on the wheel this time. I'll bet on minor injuries being below 80. I think it's going to be something like this. Okay, at this point, maybe I'll bet on the wheel landing orange. At this point, I'm indifferent. All right, so I click indifferent. So I've now done the 6 assessments. There are no more to be done. So I go to the plot and I see the numbers have been filled in here. Let's see how this turns out. Oh, look at that. I click next and now I have a distribution. And this distribution, the important thing to remember is that this is really about whether the distribution matches what I want to communicate. So I need to look at the CDF, the cumulative distribution function, and see these are the points that I assessed. What I'm really saying is there's a 90% chance that the number of injuries, minor injuries, is below this amount, which is about 140 roughly. So that sounds about right, but there's more of the 50% one is more interesting. Let's see, this is about 61, below 61. Now, how do I read that? So you can see this here, high, medium, low. This basically shows me that the discretized form of this distribution is this. So there's a 25% chance it's around 27, 50% it's around 61, and 25% chance it's around 133. Now I might find that, hey, you know what, this is fine, the distribution is more skewed to the left, which is how I wanted it to be, but I want this tail to be a little more narrow, as in I don't believe there's so much chance that it'll be above 100. So I can actually adjust this. So the way to do that would be, so I'd look at 120. So look at this, 80, below 80 and above, and below 120, they have the same probability, and that's probably not right, as in that's not what I wanted to communicate. So let's change this. There is, let's say, a 92% chance, 92% chance that it's below 120. That will make the tail a lot more narrow there, and you can see that the high value has gone down to 124. Let's keep going. I'm pretty sure it's going to be below 80, so let's make this 90% chance that it's below 80. Okay, look at that, the distribution gets even narrower, and we have the high around 118, which is I think what I wanted to communicate in this. So, and what about below 20? Is it really a 6.25% chance below 20? No, I think we're going to at least see about 20. So maybe I'll make this more of a 2% chance. See what that does. Makes it steeper. What about below 50? 25% chance. I would say there's more chance, maybe 40% chance there. Okay, I think this is a distribution I can live with. This kind of accurately communicates what I want. So I'm going to end up clicking finish. And what that did was, if you go to minor injuries given success, you will see here 117, 44, and 27. These were the 3 numbers that came out of the discretization. So now I can go ahead and evaluate with this, and I'll get the results of the model. I can do the exact same process for minor injuries given failure. So I'm not going to repeat that because it's the same process as this one. Thank you so much for watching, and happy assessments.